February 24th, 1944. The muddy back roads south of Cisterna, Italy. American tankers from the 1st Armored Division crouched beside a massive German Elefant tank destroyer, its engine burned out and its crew long gone. The 70-ton beast sat silent, its heavy armor scarred by futile American shells that had ricocheted harmlessly off its 200mm frontal plate. But as the American crews examined this German monster up close for the first time, something made them pause. There was no machine gun, almost none at all. These veterans had battled German armor from North Africa through Sicily and now into the rugged hills of Italy. They knew every panzer, every assault gun, every tank destroyer the Wehrmacht had fielded, and every single one bristled with machine guns for close defense. But this Elefant had only a single ball-mounted machine gun fixed in the front hull. Nothing on the sides, nothing on the rear, nothing on the superstructure. The realization hit them immediately. This seemingly invincible machine, with armor thick enough to shrug off American tank rounds and a gun powerful enough to kill from 3 kilometers away, could barely defend itself from a single infantryman, with a grenade approaching from the flanks. The Germans had built one of the most heavily armored and most powerfully armed tank destroyers in the world, but had given it almost no means of protection against close-range attack. The discovery confirmed what intelligence reports from the Eastern Front had already suggested. The Ferdinand, later renamed Elefant, was both a triumph of German heavy armor engineering and a disastrous failure of practical design. Its story would reshape how American designers understood the balance between firepower, armor, and battlefield survivability. To understand how such a flawed masterpiece came to exist, you have to look at the Ferdinand's unusual origins. In 1942, the German army held a competition for a new heavy tank that would dominate the battlefields of Europe and the Soviet Union. 2 companies competed. Henschel and Sohn submitted a conventional design with the turret centered on the hull, while Ferdinand Porsche, Hitler's personal friend and a celebrated automotive engineer, proposed a radical concept using an electric drive system with the engines placed mid-hull. Porsche was so confident his design would win that he ordered 100 chassis built even before the competition had ended at the Nibelungenwerke factory in St. Valentin, Austria. But his confidence was misplaced. During the evaluation trials at Böblingen in April 1942, Porsche's tank struggled badly in mud and suffered constant mechanical breakdowns with its experimental petrol-electric transmission. Henschel's more reliable design won the contract, becoming the now legendary Tiger for use that left Porsche's 100 completed chassis without a purpose. Rather than scrap them, German High Command decided to convert them into heavy tank destroyers. Engineers moved the engines to the front and built a massive fixed fighting compartment at the rear to house the main gun. The result was the Panzerjäger Tiger P, officially designated ZKFC 184, but known universally as the Ferdinand, after its ambitious designer. 91 of these vehicles were converted between March and May 1943. The specifications were astonishing. The Ferdinand weighed roughly 65 tons, making it one of the heaviest armored vehicles in the world at the time. Its frontal armor was an incredible 200mm thick, created by bolting an extra 100mm plate to the original 100mm hull front. That was twice the armor thickness of the Tiger Y. No Allied or Soviet anti-tank gun in 1943 could penetrate that armor from the front. Its main weapon was the 88mm Panzerjäger Kanone 43 2L71, one of the most powerful anti-tank guns ever mounted on a tracked vehicle. It could pierce 190mm of armor at a range of 1,000 meters, easily destroying Soviet T-34s at distances of over 3 kilometers. Soviet crews later reported being knocked out by Ferdinand so far away that the German vehicles appeared as little more than distant specks on the horizon. Inside the armored casemate, 4 men served the gun, led by a commander who coordinated fire. The gunner aimed and fired, and 2 loaders serviced the massive 88mm rounds. The driver and radio operator sat in a separate compartment at the very front of the hull, completely isolated from the fighting compartment. Communication between the front and rear crew positions was only possible by radio, an unusual arrangement that would prove problematic during combat. But the Ferdinand had serious weaknesses beyond its lack of defensive armament. The 2 Maybach KL-120 engines, originally designed for much lighter vehicles, struggled to move the 65-ton mass. Maximum road speed was only 30 km/h. Cross-country speed dropped to a crawling 10 km/h. The complex petrol-electric drive system was sophisticated but temperamental, prone to overheating in the confined engine compartment. The suspension system lacked return rollers, a cost-saving measure that dramatically increased track wear. The tracks themselves, already stressed by the enormous weight, wore out quickly. Spare parts were chronically short. The vehicle's cross-country range was only 90 kilometers before requiring refueling. Recovery of damaged or broken-down Ferdinands required multiple Bergpanzer IV. Recovery vehicles working together as a single vehicle could not move the massive weight. All 91 Ferdinands were assigned to 2 heavy tank destroyer battalions. Saga Abteilung 653 received 45 vehicles. Saga Abteilung 654 received 44 vehicles. Together, these battalions formed Heavy Panzer Regiment 656 under the command of Ost Rudolf Gill. The combat debut came at the Battle of Kursk in July 1943 operation. Citadel represented Germany's attempt to eliminate the massive Soviet salient around the city of Kursk. Through a double envelopment, Adolf Hitler had postponed the offensive repeatedly, waiting for new weapons like the Panther tank and the Ferdinand to arrive. He believed these wonder weapons would offset Soviet numerical superiority and deliver decisive victory. 89 Ferdinands deployed for the northern pincer of the attack as part of Field Marshal Walter Model's 9th Army. Before combat even began, 6 vehicles had to be withdrawn for mechanical repairs, a troubling sign. The remaining 83 Ferdinands prepared to spearhead the German assault. On July 5, 1943, at approximately 0530 hours, Operation Citadel began. The Germans launched their attack following a massive artillery bombardment. The Ferdinands rolled forward as part of the assault spearheads, their mission to destroy Soviet anti-tank guns and tanks at long range, allowing lighter German armor and infantry to advance. Initially, the Ferdinands performed exactly as designed. Their powerful guns destroyed Soviet tanks before the T-34s could close to effective range. Their thick armor shrugged off Soviet anti-tank fire that would have destroyed conventional German tanks. Soviet tankers were shocked by shells bouncing harmlessly off the 200mm frontal armor. Some Soviet tank crews abandoned their positions rather than face the seemingly invincible German monsters. But Soviet defensive preparations were far more extensive than German intelligence had estimated. The Central Front alone had laid over 400,000 anti-tank mines across multiple defensive belts. The Ferdinand's great weight made them particularly vulnerable. When a mine detonated under a track, the resulting damage often broke the suspension, bent the track itself, or destroyed road wheels. The 65-ton weight made field repairs nearly impossible. Of the 45 Ferdinands from Schwer Panzerjäger Abteilung 653 committed on the first day, all but 12 were immobilized by mine damage before 1700 hours. Most would eventually be repaired and returned to service, but the recovery of such massive vehicles from an active battlefield proved extraordinarily difficult. Soviet demolition teams went out at night to destroy abandoned Ferdinands with explosive charges. Even more devastating, Soviet infantry quickly discovered the Ferdinand's fatal weakness. The vehicle had virtually no defensive capability against infantry attack. The main gun had limited traverse and could not depress far enough to engage targets close to the vehicle. There were no machine guns anywhere on the vehicle for close defense. Once Soviet infantry closed the distance, Ferdinand crews had few options. Soviet infantry tactics adapted within days. Special anti-tank teams learned to let the Ferdinands pass over their positions in trenches and foxholes. Soviet soldiers had undergone training to overcome tank phobia, including exercises where tanks drove directly over occupied trenches. Once the Ferdinands passed the first defensive line, infantrymen would emerge from cover with PTD-41 anti-tank rifles, demolition charges, and Molotov cocktails. The PTD-41 rifle could not penetrate the Ferdinand's thick armor, but it could damage the engine deck, tracks, and vision blocks. A well-aimed shot to the engine grills could start fires or damage cooling systems. Shots to the tracks could immobilize the vehicle. Once a Ferdinand was immobilized, Soviet infantry swarmed it with Molotov cocktails and grenades. Molotov cocktails splashed burning fuel across engine decks. Grenades dropped onto ventilation. Grills filled the interior with smoke and shrapnel. Ferdinand crews were trapped. They could not see infantrymen crouching beside their vehicles due to extremely limited vision. They could not shoot them because there were no machine guns. They could not drive away if their tracks were damaged. Their only option was to abandon the vehicle and try to reach friendly lines on foot, which often proved fatal. Some desperate crews attempted improvised defenses. A few tried firing their personal MG-42 machine guns down the barrel of the main gun, traversing the entire 88-liter gun to aim at attackers. This proved absurd, dangerous, and largely ineffective. Other crews opened hatches to fire pistols and submachine guns, exposing themselves to enemy fire. These desperate measures rarely saved the vehicle. The Battle of Kursk turned into a disaster for the Ferdinands. While they achieved impressive kill ratios when engaging Soviet armor at long range, they suffered devastating losses to mines and infantry attack. German records claim Schwerpanzerabteilung 653 destroyed 320 enemy tanks while losing 13 Ferdinands in combat. Combined claims for both battalions exceeded 500 Soviet tanks destroyed. However, these impressive statistics masked the reality. Most Ferdinand losses came not from enemy tanks, but from mine damage, mechanical breakdown, and infantry attack. The vehicles that excelled in long-range defensive combat were being misused as breakthrough weapons in offensive operations across heavily mined Soviet defensive belts. By July 12th, when Hitler cancelled Operation Citadel following the Allied invasion of Sicily, roughly 50 Ferdinands remained operational out of the 89 that began the battle. The Kursk experience forced German commanders to acknowledge the Ferdinand's critical design flaws. In fall 1943, all surviving Ferdinands were ordered back to Germany for comprehensive modifications. The refitting process took several months at Nibelungenwerft. Engineers added a ball-mounted MG-34 machine gun in the hull front for the radio operator position, giving the vehicle at least some defensive capability against infantry attack. They installed a new commander's cup-up with 7 vision blocks, the same type used on the Stud 3 assault gun, dramatically improving the commander's ability to observe the battlefield. They applied Zimmerit anti-magnetic mine, Pastato the hull, and superstructure. They improved the engine grille design to provide better protection. The modifications added 5 tons to the vehicle's weight, bringing the total to 70 tons. No improvements were made to the engines or transmission, so the already underpowered Ferdinand became even more sluggish. On May 1, 1944, Hitler personally ordered the vehicle officially renamed from Ferdinand to Elefant. In February 1944, 11 of the newly modified Elephants were rushed to Italy. The first company of Schwer Panzer, Saga WW2 commanded. By Lieutenant Hellmouth, Ulrich deployed to counter the Allied landing at Anzio. American and British force had landed south of Rome in an attempt to outflank the German defensive lines. The mountainous terrain of Italy proved even more challenging than the Russian steppe. Narrow mountain roads with steep grades and hairpin turns were never designed for 70-ton vehicles. Bridges built for civilian traffic could not support the Elefant's weight. The vehicles had to forge streams, climb rocky slopes, and navigate terrain that challenged even much lighter tanks. Mechanical breakdowns were constant. The stressed engines overheated on steep climbs. Transmissions failed under the strain. Tracks wore out at alarming rates with no replacements available in Italy. When an Elefant broke down on a narrow mountain road, it blocked the entire route until it could be recovered or pushed aside. American tank crews got their first close look at an Elefant when vehicle 102 from 2nd Company broke down with engine fire nearer in late May 1944. The 3E crew abandoned it, and American engineers examined it thoroughly. They confirmed what intelligence reports from the Eastern Front had indicated. The vehicle possessed extraordinary armor and firepower, but suffered from critical vulnerabilities. American intelligence reports noted the Elefant's extremely limited crew vision, particularly to the sides and rear. The single hull-mounted machine gun provided inadequate defensive fire, covering only a narrow arc directly forward. Most significantly, the vehicle's great weight and underpowered drivetrain made it highly vulnerable to mechanical failure. American forces concluded they need not fear this vehicle in offensive operations, as it would likely break down before reaching the battlefield. American tactical doctrine emphasized avoiding frontal engagements where the Elefant's armor and gun gave it overwhelming advantage. Instead, American forces maneuvered to attack from flanks or rear, waited for the vehicles to break down, or called in artillery and air support against the Elefant's thin side and rear armor. Even American 75mm guns could achieve kills. Of the 11 Elefants initially sent to Italy, at least 3 survived to be evacuated in August 1944. The others were lost. Throughout the spring and summer of 1944, Ferdinand, 1-14, was destroyed. March 1st, Ferdinand, 131, was knocked out. March 2nd, Ferdinand, 113 was lost. May 25th, multiple vehicles were destroyed in June fighting around Cisterna. Most losses resulted from mechanical breakdown rather than enemy action. The Freikorps 211.0 captured Elefant Vehicle 102, which had originally been Ferdinand 633T. Kursk was eventually shipped to Aberdeen Proving Ground in Maryland for detailed testing. American engineers conducted extensive evaluations to identify the vehicle's true strengths and weaknesses. Their tests confirmed that while the Elefant was formidable in its intended role, it proved highly impractical under real battlefield conditions. The remaining Elefants on the Eastern Front continued to see action through 1944, primarily in defensive operations across Ukraine. 2 companies, totaling 28 vehicles, were deployed to reinforce Army Group South near Tarnopol. When used correctly, positioned in ambush with infantry protection, the Elefants were effective. But there were never enough of them to make any meaningful strategic difference. Attrition from combat, mechanical failure, and lack of spare parts steadily reduced their numbers. A few surviving Elefants took part in the desperate defensive battles of the Soviet Vistula-Oder offensive in January 1945. As Soviet forces advanced deep into Poland, the last operational Elefants fought south of Berlin in April 1945. By the end of the war, only 2 Elefants remained intact. One Ferdinand, captured by Soviet forces at Kursk in July 1943, is now displayed at the Kubinka Tank Museum near Moscow. The other, captured by American forces in Italy, resides today at Fort Gregg Adams in Virginia. The enduring question remained: how could German engineers design a 65-ton tank destroyer with almost no defense against infantry? The answer lay in the vehicle's improvised origin and the flawed assumptions built into German armored doctrine. The Ferdinand was never intended to operate independently. German combined arms doctrine called for tank destroyers to fight alongside infantry, which would protect them from close assaults, while the tank destroyer engaged enemy armor at long range. On paper, the doctrine was sound. In practice, infantry often couldn't keep pace with the heavy vehicles, especially across minefields or fortified terrain. They were frequently pinned down by enemy fire while the Ferdinands advanced. Poor visibility, night operations, or confusion often separated the two. Any of these situations left the Ferdinands vulnerable, and all occurred frequently at Kursk. German engineers had become overly confident in their armor design philosophy. They prioritized maximum protection and firepower, assuming tactics and discipline would compensate for other weaknesses. The designers believed the thick armor would shield the Ferdinand from anti-tank fire and that its long-range 80mm gun would keep enemies at a safe distance. What they failed to address were close-range infantry threats. Ad point fidi, mistake made worse by years of combat. Experience showing that isolated or immobilized tanks were extremely vulnerable. The absence of adequate machine guns wasn't an oversight. It was a deliberate design decision. It reflected an over-reliance on doctrine that proved disastrously unrealistic in actual combat. The Ferdinand was optimized for a very narrow tactical role: long-range anti-tank engagements from prepared defensive positions with guaranteed infantry support. When used under those exact circumstances, it was devastatingly effective. But war rarely offers ideal conditions. For American tank designers, the Ferdinand, later renamed Elefant, provided invaluable lessons in what not to do. It demonstrated that impressive technical specifications don't automatically translate into battlefield effectiveness. A vehicle could have the thickest armor and the most powerful gun in existence, and still fail, if it couldn't be maintained, reach the battlefield, or defend itself. American tank destroyer doctrine emphasized entirely different principles. Vehicles like the M10 and M36 had thinner armor but were faster, simpler, more reliable, and equipped with multiple machine guns for close defense. They valued mobility and maintainability over brute protection. The contrast was striking. Germany built the ultimate defensive tank destroyer and discovered that ultimate defense meant nothing if the machine couldn't survive long enough to reach its position. America built less glamorous, but far more practical vehicles that consistently performed under real combat conditions. The story of the Ferdinand Elefant remains a cautionary tale about over-specialization in weapons design. When circumstances matched its narrow purpose, it was almost unbeatable. But when conditions changed, as they always do in war, its flaws became fatal. Minefields immobilized it. Mechanical problems sidelined it. Infantry destroyed it. It consumed vast resources while contributing little to Germany's strategic fortunes. Today, military historians study the Ferdinand Elefant as a textbook example of theory clashing with reality. It is featured in armored warfare courses as proof that specifications on paper can conceal critical operational weaknesses. It shows that weapons must be designed for the unpredictable chaos of real combat, not for perfect laboratory conditions. The two surviving vehicles stand as monuments to both German engineering brilliance and the limits of over-specialized design. Museum visitors are awed by the enormous gun and massive armor, until they notice the single fixed machine gun covering only the forward arc. Then the flaw becomes obvious. The most powerful tank destroyer of 1943 could be defeated by a single soldier with a grenade. For Soviet infantrymen at Kursk, that weakness became a deadly opportunity. They developed tactics specifically to close the distance and destroy these steel behemoths with weapons as simple as Molotov cocktails. For American tankers in Italy, the knowledge of its poor reliability and limited defense reduced the terror it once inspired. They learned to avoid its front and instead attacked from the flanks, or simply waited for it to break down. Ultimately, the Ferdinand Elefant proved that victory in modern warfare doesn't come from building the most powerful weapon, but from building the most practical one. The tank destroyer that could barely protect itself became a perfect example of flawed design philosophy, a lesson that influenced armored vehicle development for decades. Ferdinand Porsche's ambitious creation remains one of the most controversial weapons of World War II. It achieved impressive kill ratios when used as intended and inspired fear among enemy crews. But it also consumed immense resources, suffered catastrophic losses to basic threats, and failed to alter Germany's fate. The Ferdinand Elefant stands as proof that in war, functionality outweighs perfection, and that the most advanced weapon isn't always the most effective one.